So today we're on the Mendip Hills of southwest England, and we're actually on the south side of Blackdown Hill, where small streams gather and flow to the south, and they reach the limestone, flow down some of those valleys, and then sink into a number of different caves. Charterhouse Cave to my behind me, and then GB Cave, where we're going today, just over there. And the area around here is very uneven, and it's locally known as gruffy ground. And it's the remnants of lead mining, much of which dates back to Roman times in this area, probably a little bit later, but certainly 16th, 17th century, where the ground has been repeatedly turned over in search for galena lead ore.
Okay, you see that I'm sitting amongst all the stalagmites on the ground and some stalactites on the ceiling, which are taking the groundwater that has been dripping through the superficial limestone. When the water is above in the soil, it picks up carbon dioxide from all the biological activity above, and that carbon dioxide produces dilute carbonic acid, which, as it drips through the limestone rock calcium carbonate, it will dissolve a little bit. Now, not very much, but it means that the water dripping through is hard water, mineral rich, and when it emerges into the cave, so many popular books will suggest that it's caused by evaporation, but actually evaporation is really rare in caves. So all the ones you can see around me, they're formed essentially by the degassing of the carbon dioxide that the water absorbed up in the soil. And then because it's no longer carbonic acid, it can't keep the calcium carbonate in solution, so it deposits them. Now, some of the interesting bits about stalagmites is obviously that layer by layer they build up, so that in sequence, year by year, you'll know that the lowest on the very bottom is the oldest, and then on the top is the youngest. And I thought it would be of interest for you to see. I've got a stalagmite that has been cut, obviously not from this cave, but it's been cut across. I'm not sure if you can see it from there, but I'll show you later. See that little stalagmite that's been cut across? It does come from an area with a bit more activity than here. If I were to cut one of these, they're probably all white throughout. But this one does show you the sequential layers of growth. Now, it's very likely that each of these layers represents some event in the climatic history, such as a flood event. One of the features of this cave and many of the caves in Mendip is that in 1968 there was a very big flood, and so many of the caves slightly altered the course because mud and debris was washed out, so new passages appeared, but also some of the lower lying stalagmites would have a layer of mud covering them, indicating that past flood. And the example I've got here shows a series of mud layers, probably related to a series of storm events in the cave from which this came. You can use the evidence in the layers of a stalagmite to indicate things like former climate change or former flood events, and sometimes simply former events in the history of a region. Now, right where we are, the bridge, a sample was taken from this in the 1970s. Many samples were taken from McMaster University for PhD studies, taken from this bridge area. And one of them was only about 10 centimeters tall. So Don McFarlane and myself did a cross-section through it, the dates of each of the layers, and then the lead record. And the lead shows when the Romans were mining. There's a lead spike for the Roman mining. There's also then, during medieval times, very little. There's a little bit more late medieval mining, and you see a spike then, and then it stopped. And then you get the 17th, 18th century resumption of mining, and another spike in the lead. And then finally, the modern lead pollution from all the petrol. So stalagmites can show you even events in the prehistory of humans, as well as perhaps pollution. I haven't really done many studies yet of pollution evidence in the stalagmites. Some of the other bits of evidence in, say, Belize, you can see the hurricanes in the past, because every time there's a hurricane, there's a layer of stalagmites, a layer of calcite, which shows you the chemistry of it changes with the hurricanes. Okay, I'm through.
All right.
If it was anyone else but Joyce, there'd be some serious bad language right there.